Good afternoon, everybody. I hope you all are doing well. And once again, thank you guys so much for being here, for showing up and supporting your local library and attending our programs. Take it from me, we really appreciate it that you guys come out in person to things like this. And if there's anybody watching online, thank you guys as well for just tuning in and wanting to know a little bit more about the programs and things that we offer here at the library. So without further ado, let's go ahead and talk about some recording studio basics. If you haven't heard, the library, as of about a year and a half ago, we added 2 brand new recording studios. This program was something I originally conceived around the time that those were being constructed, just to kind of guide people through those first beginning steps of getting started in the studios. So let's go ahead and first of all, I'm going to give you guys just a little bit of background about myself, not out of any sort of hubris or anything, just to let you guys know that I know what I'm talking about. Wonderful year and a half. I have it's been 2 years. Oh my gosh, it's been 2 years. It's been a great 2 years. It's been a fast 2 years. But before that, I was an assistant manager at a recording studio down in Nashville for just a little while. Before that, I was an intern at that studio. And then before that, I was taking an audio engineering certificate program down in Nashville. And then before that, even I specialized in music technology and recording techniques in my music business bachelor's in college. So all that to say, I've been in production teams and behind, gigantic 48, fader consoles, and I've helped people record everything from just like 2-person interview podcasts to like full jazz bands and things like that. So just so you guys, again, know that I know what I'm talking about when I start giving you all of these, big things about audio and production. So enough about that. Let's actually take a step back from everything, and before we start diving into a bunch of technical gobbledygook about microphones and interfaces and all that good stuff, let's go ahead and first of all define what is a recording studio. It is a bit of a rhetorical question. The definition I could come up with is that it is a room that is specifically designed for capturing the best sounding audio onto a recorded medium. So for the longest time, getting ahead of myself, but the audio is captured through the available equipment like microphones, recording interfaces. This could be also some outboard gear that we do not have in our studio. And then it is sent to a machine that captures it. In our case, that's going to be a computer, but that was not always the case. For the longest time, we recorded everything to magnetic tape. So you got to think those big reel-to-reel tape machines that you've seen in pictures of, big professional recording studios and things like that. Yes, if you guys want to take pictures of the screen, please go right ahead. But nowadays we use a series of programs called digital audio workstations or workspaces, or DAWs. DAWs come in many different shapes and sizes. It's really all about what kind of experience you want. Personally, here at the library's recording studio, we use a program called Waveform 13. Not only because it is in my opinion, very simplified and easy to approach compared to a lot of other programs like this, it's also one that is completely free to download. So I really encourage people to get it on a computer at home, maybe try it out, do some work on it and things like that. The other thing we're going to be checking out today is actually an online digital audio workstation called soundtrap.com. So that is completely free as well. You guys can access that not only just right there in your browser, so you can have it at any time. It's an even more simplified version of all these giant, big ones that professional recording studios use. Up next. So studios are run by what we call audio engineers, who capture the best sounding audio by having a full understanding of not only what is being recorded or the source, the equipment that is being used, and then of course the actual physical acoustic space, so the actual room that you are standing in. These things are very, very important. I'd call these the 3 hallmarks of audio engineering: having an understanding of the source, the room, and the equipment. Those are very, very important things to have because all three of those elements are all going to work together to create a unique sound. Pretty much everything that makes a sound has its own distinct frequency blueprint, basically, or fingerprint. It's just as unique as a fingerprint. Combine that with the the type of equipment that that we use. You'll hear me say a lot in this. Not all audio equipment is made the same. Not all audio equipment is equal. There are microphones that are good for some things and not as good for others. There are this thing that is good for this thing and that thing that is good for that thing. And then finally, the physical acoustic space. You just want to ask yourself questions like, what are the walls made out of? Are they stone? Are they drywall? How are they reflecting sound? What's the ceiling made out of? Is it tile? Is it, spackle? Is it whatever? What's the floor made out of? Is it carpet? Is it tile? Is it reflecting sound? Is it absorbing sound? We're going to talk about a few of these things here in just a little bit. But we're definitely going to be focusing on the equipment being used here. And kind of going into why we picked out what we did for our studio and then helping you guys get started with some of these programs. So the next thing I want to take a look at is this concept in audio engineering. Now that we're getting into the actual technical side of things, this concept called signal flow. Signal flow is something that's very important to audio engineers because it is how a recording goes from being sound, so just an airwave that's being cast into the world, into oblivion, to actually being signal or being converted into an electrical or a digital form where then it can be recreated as sound using speakers or something like that. So typical studio signal flow is going to look like this. And I'm going to hit this one slowly because I know there's a lot of blanks here. You are going to start with your source. Your source is whatever is being recorded. So this can be your voice. This can be your buddy's voice. This can be a guitar, piano, drums, whatever, what have you. It is just whatever you are putting a microphone in front of. Speaking of that, microphone is going to be the next step in the signal chain. This is going to be the device that captures that audio and then sends it down the line of the rest of our flow here. So once it has hit that microphone, it is going to go down a cable, much like the one that's plugged into my microphone here, into an interface input. An interface is a box, if we can see this, that kind of looks like this. This is the one I'm currently using for this stream as I look over at my volume meter to make sure I didn't just ruin anything. But basically, it is a device that accepts this electrical signal from the microphone and takes it and converts it into a bunch of ones and zeros or binary code that the computer can then understand and recreate itself. But to do that, it needs to go through two different processes inside the interface here. So it's going to go through a preamplifier, which is going to take this very, very, very quiet microphone signal and turn it up to what we call line level. That term will come back again when we talk about the interface and what line level entails. But basically, you can think of line level as the minimum amount of volume that a sound needs to be able to be heard by the equipment being used, basically. It's kind of a dirty, quick explanation of that, but it works. Next, that preamplifier, once that sound is nice and loud, our device can actually hear what's going on. It's going to be sent to that digital converter, get turned into that nice code that the computer can then recreate, and then from there, it is going to be sent to our digital audio workstation. And then this is kind of the final step in the input signal flow. So whatever is going into our recording program. So the flip side of that is going to look very similar, but just reversed. So the last part of that is going to be, why is it not doing, why am I pointing at that? Obviously, the first point there is going to be the digital audio workstation. And then from there, we are going to go not to the interface input, but to the interface output channel. So down this channel, there is going to be an amplifier for the there's actually, before the amplifier, there's going to be an analog converter that's going to take that digital code from the computer, from the digital audio workstation. It's going to turn that back into an electrical signal. Then the analog converter is going to shoot that over to the headphone and speaker amplifier, or headphone or speaker amplifier. In our case, we unfortunately don't have any speakers in our studio, so that is just the headphone amplifier. Next up, it is going to go from that output channel, I keep pointing at the screen, and then it is going to hit our headphones and our speakers. And then from there, it hits our ears and gets turned and digested in our brain, and we know what we are listening to. So this is a lot of arrows and pointing and things like that, and I always get asked, does anybody need any more time on this screen? Real quick. Yes?
So the question on the return, it goes from the DAW to the interface output channel, then down to the analog converter?
Yes, exactly. Yeah, that's kind of like representing what's going on in the, inside of the interface output channel. Yeah. But I get asked all the time, hey man, I'm just a rapper. I just want to, I just want to stick a microphone in front of my face, do my thing, and then just get out of there, In that case, I say, great, go hire an audio engineer. That is the exact way that you can do that. If you don't want to know any of this, you don't have to, because there's guys like me out there that find this stuff just simply so fascinating we can't help but not learn it. So why do we need to know this? There's a lot of technical things involved in audio engineering, and people oftentimes get really, really, really stuck on just trying to figure out what I need to know, what I don't need to know, and all of that sort of thing. So I found this today, honestly. I found it from this blog down there from, I think it was like from like Jazzy LJ or something. But this is kind of a history of recording. I've tried many times to add an entire history of like audio engineering and stuff to this, and it always ends up making this entire program like 30 minutes longer. So, but this I found, and it's a really good representation of where we started versus where we're at today, kind of 1998, whatever, obviously we have streaming and things like that now, but that was really just kind of the natural progression from MP3s. But I want to point out that the earliest form of recording only appeared in 1857. That's the earliest, most rudimentary form of recording. Recording and audio engineering, we didn't even get to magnetic tape until the 1940s. That was less than 100 years ago. And then we didn't even get to what we're using now, which is, digital files and MP3s until the 1980s. And we didn't even get really good at making digital files until the 1990s. All of that to say is that audio engineering is still, compared to a lot of the other sciences, is still a very, very young science. There's still a lot that we're figuring out about it, and it's still not a perfect system yet. It is incredible what we can do with audio in the year of our Lord 2026. It is incredible. There are wonderful, amazing, crazy programs out there that can literally display the entire frequency spectrum of a sound and allow you to edit out parts of it. It's crazy. It's called Isotope RX. It's one of the coolest things ever, and it costs a lot of money. But I point this out just to say, we as audio engineers, we as guys who have been doing this, our whole careers, we are still just figuring stuff out just the same way that beginners are. We are still learning new things about audio every single day because it's weird. Sound is weird. Waves are weird. They move in weird ways. They interact in weird ways, in ways that we still don't fully 100% understand. We understand a lot of it, like a really, really big amount of it, but we're still working on it. So all of that to say is that if you're struggling with something, if you're getting hung up on, this technical thing of it, go on YouTube, crack open a book, and get into learning about it, because I guarantee nothing in the world beats the joy that you get when you go, oh, I get it now. Oh, I get what's going on now, because that, trust me when I tell you, like you'll get that first recording back and you'll be like, man, I sound bad, but that sounds cool. Because trust me, nobody likes the sound of their own voice when they're recorded, especially not me. So again, all of that to say is just like, I don't know. I was just thinking about that earlier today, that just 1857 was the first time we even had sort of a figure, kind of a figuring out of how we could maybe start to save vibration, which is the craziest thing about this. So, but beyond that, I have a couple of other things to say about this. Being familiar with the audio setups will help you understand what is happening to what is going on with how things are being recorded and how the different parts of the studio are affecting it. Like this microphone. This microphone, the pod microphone, we're going to talk about it here in a bit, but it's specifically tuned for recording voices. So if I slapped this on a piano, I could record with it. I could record, but it probably wouldn't be as good as if I had slapped another type of microphone on there. Next up is that, again, not all audio equipment is made equally. There are different pieces of equipment that have unique applications in the studio. Obviously, a microphone is not an interface. Microphone is just a thing that sends electrical signal. That's all it does. The interface is what actually helps it talk to the computer. But likewise, like I just said, there are different types of microphones. There are different types of interfaces. We have a 2-channel interface here because I only need 2 microphones. But a big recording studio that's trying to capture a metal band with 4 guitarists and 2 drummers is probably going to need a lot more than 2 microphones. Therefore, you're going to need a much, much, much bigger interface. Up next, knowing the different parts of the studio and what they are used for gives you a foundation for getting the best sound possible. Once you start to figure all of this out and you start to say, okay, well, this microphone is best for recording voices, why don't we just use this on our podcast? Things like that. So let's go ahead and break down the setup and the signal flow of our recording studios here at Bloomington Public Library. First up, we are going to look at just like the whole signal flow here. So we've got our source, which is just going to be, probably you or a friend or whatever. And then that is going to go here to the Rode pod mic. From the Rode pod mic, we are going to go to the M-Track Duo from M Audio. And then up next is going to be Waveform or Soundtrap, or OBS, which is our streaming software. And likewise, on the back side of that is going to be your program, so, for example, Waveform. Then it's going to go back to the M-Track Audio, M-Track Duo, and then it is going to go down to the Behringer headphones that we have, and then finally it's going to hit our ears. Now, that's all great. Those are words. That's very nice. So let's actually talk about these individual parts and explain why I picked these things out, why we are using what we're using, and how you guys can use these to get the best sounding audio possible. So first up, the dynamic is the Rode pod mic. It is a dynamic broadcast microphone. Those are just words that I have strung into a line. Those do not have any meaning in your brain. So let's give it some meaning. So dynamic refers to the way that this microphone works. There are 3 main types of microphones. Dynamic, which uses this system, which is a coil of wire around a magnet, otherwise known as an electromagnet, that is put in front of a metal plate. Next up is called a condenser microphone. You guys don't need to write this part down, but basically a condenser microphone uses a capacitor and a metal plate to create the same effect. Those are typically a lot more sensitive and require a little bit extra power to get sound. You don't need to write that part down. That's not important. That's not as important. The final kind is called ribbon. Ribbons use a literal string or a ribbon of aluminum inside of them that vibrates whenever air touches it, and that is how it can send an electrical signal. But for now, again, we're going to focus on dynamic. So a dynamic microphone uses a coil of wire around a magnet that generates an electrical charge when it vibrates. So inside of here, we have a metal plate, and then right behind that metal plate is a magnet. It is a very, very thin metal plate, and that metal plate is called a diaphragm. So what happens when my voice hits that diaphragm is that diaphragm starts vibrating ever so slightly at the same rate as my voice. It is kind of crazy. And then if we can kind of think back to like our high school physics class, whenever we put a piece of metal inside of an electrical field and start moving it around, does anybody know what happens? Yeah, basically it generates a charge. Yes, it generates a charge. So on that metal plate, there are two wires called nodes that link up with this here microphone cable. And from those wires, whenever that plate starts moving with the vibration of my voice, it's going to vibrate at the exact same frequency as my voice. And therefore, it's going to send an electrical charge of the same frequency down those wires into this and then into our interface. We're getting very sciencey right now, so we're going to dial it back. Basically, we have a system that requires very little power to operate and can function on its own very well. That's what makes, but you do need a little bit more force on the end of the source to try and get it to work sometimes. So this is what we would call a low sensitivity microphone. There's high sensitivity and low sensitivity. Obviously, high sensitivity is going to pick up like everything in the room all the time, sort of. But low sensitivity is going to be, you may need a little bit louder, maybe a little bit more power to get some good sound through it. The reason I chose this is because libraries are naturally very quiet areas, but, not everywhere all the time. There are people that walk around. When you walk around, you stomp, you create vibrations in the floor. That vibration is going to go up through the walls and the desk, and it's going to shake the microphone ever so imperceptibly, but the microphone will still feel that, and it will still hear that. Likewise, there might be somebody having a conversation going on outside. There might be, I don't know, like the air conditioning unit might be running, and it might creating this low hum in the room and things like that. Having a low sensitivity microphone is a good way to try and get rid of all of that excess, what we call ambient noise. Just noise that's happening around your recording that isn't part of the recording and probably will not sound very good in the long run. So having a low sensitivity mic ensures that we can turn this guy up enough to capture our voice, but not a lot of whatever is going on around us. It'll still capture some of it. Yes, you still may notice, a hum or, some footsteps here and there. But for the most part, it's going to be a lot better than if we were using a really sensitive mic. Up next, we have the term broadcast microphone. This means that this microphone has been specifically designed to capture conversational vocals in a variety of different situations. And then I already explained low sensitivity. But basically, that means that we can kind of take this microphone anywhere, put it in front of somebody, and it's going to sound good on their voice. This microphone was patterned after one, just for the sake of sakes, it was the Electro Voice RE20, if you are curious about that. But that is basically the premier standard NPR mic. It is the microphone that is in every NPR studio and every talk radio studio. It is probably the one that you have seen with Howard Stern or anybody like that who's a talk radio DJ or anybody who does a lot of podcasters. Actually, a lot of podcasters have been using this now, which makes me very happy. So I kind of got in on the ground floor of this back before it was like super, super popular. But yeah, now if you're watching a YouTuber or a streamer or something, there's I would say a probably solid 6 out of 10 chance that they are using a Rode Pod mic. That being said, its frequency response is just very good for voices. So up next, we are going to talk about the M-Audio M-Track Duo and things here on the front. We've got all sorts of stuff going on. So I'm going to kind of break down these different controls and things like that, kind of starting from the top, and then we'll look at the side and then the back. So starting at the top of the interface, you will see the 2 knobs for the input channels. I guess these are this is what's going on inside first, sorry. But this guy has 2 channels for recording, like I said earlier, which means that it can support recording 2 microphones at the same time. Obviously, if I had an interface with more inputs, more things like that, I could record more microphones, but we just have 2 for now. These channels contain what is called a preamp, which is something that every interface is going to have in the world. It stands for preamplifier, and again, it just is that device that takes it and goes and takes that low signal from the microphone, and it takes it and turns it up to line level. These are specifically M-Audio's trademarked crystal preamps, meaning that they have very low, very little added noise. Anytime that you have a device with a lot of power running through it, like this guy, this is quite a small package, and there is a decent amount of power running through this. Anytime that happens, you run the risk of that extra power that is running through it ending up in the electrical signal of your audio and adding some noise. The crystal preamps are specifically designed not to do that. So when you combine that with the low sensitivity of our microphone, you get a very nice, clear sound that doesn't have a ton of background noise in it. Up next is that thing that we mentioned earlier, the analog to digital converter. This actually works 2 ways. It will convert into analog and it will convert into digital, depending on which direction the signal is coming from. So again, we are generating an electrical charge with this, and it's being sent here, and then that analog to digital converter says, oh, I know what these waves are. I can take them, and what I'm going to do is take screenshots of this wave at different points along its journey. And then I'm going to create these points, and then the computer can then kind of fill in the gaps between that and replicate that sound. That is a very, 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 very brief definition of how digital audio works. Those screenshots that I said of that wave, those are called samples. And we'll see once we open up waveform here, there is going to be a setting called sample rate. That is how many samples are being taken per second. Usually it will be something in the range of 48,000, maybe 44,100, or maybe lower than that for some older things, maybe a little bit higher sometimes. So that is kind of what the analog to digital converter does. Up next on the front of the interface, I was a little bit wrong, I'm going to explain kind of what these switches are. So underneath each of the microphone's inputs, or of the interface's inputs, is going to be a switch that has 2 symbols on it. It's going to have a box that says line in the center, or it's going to have a little icon of a guitar. Switching between that line and that guitar is going to turn on or off the line level boost. So that is because microphones, as we established earlier, usually are very, very quiet. They don't send enough power. They don't send enough power for the. They don't send enough power for the equipment to really hear it. So what it does is that it takes it and it boosts it up to line level. But there are things out there that are already at line level. There are very certain microphones, very, very, very specialized microphones, but more importantly, electric guitars, electric pianos, electric really any instruments, electric bagpipes. There's a guy that I know that has some of those, and they're awesome. But basically, switching that from line to the instrument allows you to plug in any sort of electrical instrument that is already running at line level, and it won't boost it all the way up and make everything sound distorted and nasty. Likewise, when you turn that off, you are now boosting that up so you can connect a microphone. I see a lot of people who are trying to get more sound, more volume out of this box, and so they hit that switch not knowing what it does and not knowing that they actually just made everything get a lot quieter than how it was. So if you need things to be louder, just give the knob a twist. That's all you need to do. All right, and then next we have the speaker and headphone amplifiers. Those are just right here on the front, and next to that will be the output switch. Those are just amplifiers in this thing that power the speakers and the headphones. That's really all we need to know. But the output switch is pretty important. There are 3 different positions on the output switch. There are 2 that are named direct and 1 that is named USB. We have direct mono, direct stereo, and then USB. So explaining USB, first is going to be, so flipping this switch is going to change what you're hearing. The USB is going to be whatever sound is coming from the from the computer. So this is probably going to be the one that you are going to leave it on the most, because that will allow you to hear what is happening inside of your digital audio workstation. If you switch it to direct, you are going to hear what sound is coming directly from this box. You will only very faintly hear what is happening in the computer. It will still be there a little bit, but it will be very, very quiet, so you can focus on listening coming from what is directly from the box. The direct switches are most useful for troubleshooting. Hear me now. I, again, see a bunch of people that are trying to get more sound, and they're switching the output around. And I'm like, guy, that's not getting you any more volume. That is just changing what you're hearing. So if you want to hear what's coming from the computer, leave it on USB. Otherwise, if you're having a problem, if you can't hear something in your digital audio workstation or something, you can switch that to direct and see if it's a problem with your interface. You'll switch it to direct, you'll put your headphones on and just speak normally into the mic, and then you will be able to hear or either not hear and go, okay, the problem is here in the box or it is not. So next to that is a switch called phantom power. Now, thinking back just a minute ago, I talked about a different type of microphone called a condenser microphone, and I said that it needs a little bit of extra power. That is phantom power. It is that little bit of extra power. It's 48 volts, which is really hardly anything. It's 48 volts of extra electricity that powers some microphones. The Rode PodMic does not need phantom power. Yes.
So like a Blue Yeti is considered.
Yes, it is, but the Blue Yeti specifically has phantom power already built in. So if you hooked it up to a interface, you would not need phantom power. Yes. Good question, though. But yes, I'll say the Rode PodMics do not require phantom power. In fact, if you turn phantom power on with the Rode PodMic attached, there is a low chance that you will damage it. So please, you will see this on all of both of our interfaces in there, this nice big red sticker that says, do not turn on phantom power. Please do not turn on phantom power. Turning it on in and of itself probably won't damage the mic outright, but the problem lies in the mistake that everybody makes when they turn on the phantom power. This is a mistake that I have made. This is a mistake that many of my professional audio engineer friends have made, and it's that we forget to turn it off whenever we're finished.
I'm sorry, can you show us again?
Yeah. Nice big red sticker. Do not turn on the phantom power. But then the switch is right down here. There we go. Yes. So it's just that one little switch down there that says either on or off. You can just leave that off. You don't need to touch it. A lot of people have asked me why I have not just like taped this down. I'm like, I don't want to break the switch in the off chance that we do get microphones in the future that do require phantom power, and then we're just kind of out of luck because we can't actually switch it on. So I do leave the switch uncovered and everything. But just while you're in the studio, please remember you don't need the phantom power, so just don't even touch it. It's not necessary. So that being the kind of equipment side of things, we are now going to check out some of our programs here in the studio. So the first thing I'm going to do is a very, very brief breakdown of waveform 13. Try and get my mouse to work again here. Which again is the primary program that we use here in the studio. So this is what waveform looks like. When you first come in, it will be that kind of white W with the purple highlights right there on the desktop, and this will be the welcome screen that you see whenever you first open the program. To get things started in waveform, it's very simple. You have some presets up here that you can use, but it's just as easy to hit, new project down here in the bottom. Right here in recent edits, is where any recently worked on projects will appear. This area will usually be empty, as we really encourage people to clear their projects off of the computer whenever they are finished, just so A, nobody tampers with your work, and B, just so we can keep the hard drive nice and clear and keep the computer running at peak performance. So anything that's been worked on recently will show up over there. And then we have some project templates in here that I can briefly explain. We have a podcast right here that is going to set up 4 channels for you to record on: a host channel, a guest channel, an effects channel, and then a music channel. The house of worship is kind of used by churches and synagogues and places like that that have very large worship services that contain music. Usually they will use this to kind of route their audio to their speakers, or they will use it just to straight up record their services and things like that. But this will set up a whole bunch of different channels that are all labeled with different elements and all kind of have certain audio effects already set up for them. The EDM over here is really helpful for electronic musicians. It's going to set up what we call MIDI tracks. That stands for Musical Instrument Digital Interface. And yes, I said that really fast because it is not important. Just remember, if you see MIDI, you can think of digital instruments. Up next is band recording. I feel like this one's a little self-explanatory. If you guys have like a rock band or, a punk band or something, you guys can set up with this, and it'll already have, drum tracks, guitar tracks, things like that already set up for you. And then finally, 2-channel mixer right here is very interesting. It's for DJs, and it allows you to play 2 things congruently and fade between them. So, but for now, I'm going to just be doing, I left one out intentionally. Singer-songwriter is broken. Don't use that one. It will not, if you click on this or hit new project and select singer-songwriter as your template, it will not create a project. It will just create a weird folder on the desktop with a bunch of random like audio files in it. This is a problem that Waveform has had for a while. I have contacted Traction about it, and they're like, we're trying to patch it. We're doing the best we can, and I believe them. So just for now, we'll leave that one be. The idea is that it's supposed to just set up like a vocal and a guitar track for you to record on. Very simple, but that's really simple to set up for yourself. So I am going to show you how to do that right now. So to get started in Waveform, you will just go ahead and hit New Project right here, and then you will give your project a name. Usually I like to use my own name first, and then the name of my song or my podcast or whatever I'm working on, and then I will usually put the date. And you will notice the way that I'm doing this is very intentional. I totally forgot what day it is today. 26. The way I'm doing this is very intentional. I'm not using spaces, and I'm not using dashes in my date. Sometimes spaces and dashes can help the computer get very confused as to what a file is. So as much as you can, use underscores and periods instead of spaces and dashes and things like that. So up next, and this is very important. This is the lame part that everybody talks about. This is the file saving part that every part of the video that everybody skips because this is not interesting. This is not recording. Why do I need to know this? Well, you need to know this because you want to make sure you know where your files are on the computer so that when you go to look for them, you can actually find them. Trust me, I lost an entire project like this. I did not look at where I was saving to, and I straight up could not find my project on the computer. I had to go back and redo everything. And that it was a whole song that I had been working on. There was like 10 different elements or something like that, and I had to go back and re-record everything. I had like some of the original files that I had already transferred, but pretty much everything I needed brand new versions of. So when you are creating your project, not when you are going to save it, not when you're done, when you're creating your project, take a look at this location section. You want to read this right here and make sure that it's saving this to the correct spot. I really encourage people, just so your files are really easy to find, and since not a lot else is saved to the desktop, just save it to the computer's desktop. The way you do that is by clicking right here, this little blue square. It's going to take a second to think about things, and then it's going to show up with our folders here. You will navigate over here. Oh, my battery is running low. I actually will take that. Thank you. I forgot to grab a charger. There we go. Awesome. All right. Yes, it is charging. Not very quickly, though. All right. So whenever you do, make sure you look up here and see that it says desktop. If it does not say desktop, look over here and click on desktop. You don't want to click documents. You don't want to click downloads, not music. You want to click desktop. That way, whenever you close out of waveform, all of your files will just be right there on the main computer screen, ready for you to find. Yes.
Are we allowed to bring in our own external hard drive to save our projects on?
That's a fantastic question, and I'm so glad you asked that, because yes, I actually really encourage people to do that, because it's great, especially if you have like a terabyte hard drive or something like that. You can store thousands of projects on that, and it's going to be a lot more secure than